first of all, what we need to know is about Fibonacci number. So if I just denote a Fibonacci number, then I would like to write it like that. The generalized form f of n plus 2 is equals to f of n plus 1 plus f of n. So if I just like to rewrite the Fibonacci series, so the Fibonacci series, then you will see it like that: 1 1 2 3 5 8 and so on. So just notice here, any of these numbers, if I took 3, then I can write it like 2 plus 1. Here goes 2, here goes 1. Alright, so if I write 5, then I can write it like that: 3 plus 2. Here's the 3, here is the 2. So yes, the n plus 2th term is equals to the n plus 1th term plus the nth term. So yes, hope that you can recognize the Fibonacci number. So second of all, we need to know about Lucas number. It's just an easy term, never mind. So the nth term of Lucas number, I can write it like that: L of n is equal to 2 f of n plus 1 minus f of n. So for the first term, L1, I can write it 2 f of 1 plus 1 2 minus f of 1. So if I just put the values of them, then I can write it just simply 2 minus 1 is equals to 1. For the second term, I can write it like that: 2 f of 3 minus f of 2. Alright, so for the third term, 2 f of 3, the third term goes here 2, and I can multiply it by 2 minus 1. So finally I can get 4 minus 1 is equals to 3. So the third term for the Lucas number L3 is equal to 2 f of 4 minus f of 3. So the fourth term of Fibonacci number goes for 3, so just simply multiply it by 2 minus the third term is 2. So I can write simply it is 6 minus 2 is equals to 4. So according to our findings, I can write the series like 1 plus 3 plus 4 comma dot dot dot. So yes, here goes a Lucas number, simply explained. After that, we need to know two formulas. So the first formula of our will be like that. We can say for any number 5 n square plus minus 4, if I can find this one is as an integer, then I can say this n is a Fibonacci number. Alright, so let's just take an example from our previous slides. So let's take 8. 5 into 8 square plus minus 4, it will be 64 times 5 plus minus 4, and I will get two answers. This will be 64 times 5 plus 4, and it results with 324. And if I just simply get in minus 4, then I will get 316. So if I root over them, and they will result in root over 324 is equals to 18, or simply 324 is equals to 18 square, and also in for 316, and it gives us a result. So for nth term as an integer, then fn square minus 4, if I express it like that, then it will be of a perfect square and n will be a Fibonacci number. But just for an alert, we can say that here denotes the OR. So either 5 into 8 square plus 4 will be a perfect square, or the 5 into 8 square minus 4 will be the perfect square. That means that it doesn't mandatory that the both will need to be a perfect square. As you can see, this 360, this is not a perfect square. Alright, so here goes our first formula. After that, I would like to write our second formula. This formula will include this assertion 5 f of n square plus 4 into minus 1 to the power n is equals to L of n square. You can just prove this assertion by induction, but for the time being I am not proving this conclusion, but just take it as a formula, and this will help you to solve our math. So please look at the formulas properly, and if you are ready, then let's move to our solution. Alright, so for our solution, first we would mention you that our expression D was looked like that. D is equal to 3 times P of 2022 plus minus root over 5 times P of 2022 square minus 4 divided by 2 times del by P of 2022. So first I would like to work with this del by P of 2022, this one. Alright, so our del was equals to P1 times P2 times P3 times and so on, and we ended up with P of 2021 times P of 2022. And for dividing this one with P of 2022, it means, so yes, here we are, divided by P of 2022 term. So I just cancel out this two side and I can write it like that: P1 times P2 times P3 times dot 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 and P of 2021, or P1 times P2 times P3 times so on, and it end will up with P of 2022 minus 1, which was in our last assertion if you look at the question again. So our another term has been solved, but the main issue is with this one. Alright, so if I just want to see this D as an integer, then I must work with the 5 of P 2022 square minus 4. So if this one becomes an integer, then I can perfectly say that the D will give us also an integer. And also the second question about this is that this whole term which needs to be a square number. Why? If this one becomes a square number, then the square root and the square will be cancelled out, and so we can hope for a better in output. Alright, so if I want this one as a square number, remember our first theory. So according to this n, let me clarify it properly. For this, I'm sorry, alright, so if I want to define this one with my highlighter, so where it goes, so for this n, if I denote this properly, and our this term P of 2022, if we match these two, then I can say that as a conclusion, and with my pen actually, is that P of 2022, this one is a Fibonacci number. Alright, so Fibonacci number. Okay, so in this here we will use our second formula, which was 5 of p of terms, I'm sorry, 5 of f of n. All right, so it was 5 of f of n square minus plus 4 of minus 1 to the power n is equal to L of n square. So from here we can finally say that our P of 2022 is an odd indexed Fibonacci number. Okay, so finally we can say this is an odd term of Fibonacci number. So I would like to denote this one as f of twice m plus 1, just any odd. Okay, all right, so let me clarify this one also with my highlighter, and here I think it's going to work now. Yes, this one is an important term for our denote, and you can say this one as a key term for our next steps. So let's move to our next step also. So we have written previously that d is equals to 3 times p of 2022 plus minus. So here let me clarify this whole term properly. So first, if I choose the plus one, all right, so first I would like to choose the plus one for my solution, and just for plus, and there is root over 5 times p of 2022 to the power 2 minus 4 divided by 2 times del by p of 2022. all right, so here you can see it can be concluded as 3 by 2 plus on the expression you can see from the square root divided by 2. So let me just find it with a bracket because it takes 2 times to write. all right, times del by p of 2022. So here also I can write it finally. There will be a p of 2022 be multiplied, so I can cancel out this 2, just taking it common from the both sides. So it can be written or with thought by this expression into delta, so which is obviously greater than delta. all right, so it all obviously contradicts with our last note which was written there, if you like the question properly, where this one was the main purpose of this node. okay, so this assertion and this assertion, these two basically contradicts. Oh, my bad. So here it goes, contradicts. all right, so if these two assertion contradicts, then finally we need to end up with a minus term. all right, so here we go with our final lines and be ready for the final solution. D is equal to 3 times p of 2022 minus root over 5 times of p of 2022 squared minus 4 divided by 2 into del by p of 2022. So I can write it like simply that is equals to 3 of f of 2m plus 1 minus 5 times f of 2m plus 1 squared minus 4 root over divided by 2 times del by p of 2022. all right, so from here I can write this one like that, this whole term root over 5 of f of 2m plus 1 whole square minus 4, it will be equals to a Lucas number of 2m plus 1th term. Alright, so yes, this was according to our second theorem, so I can just divide it simply with 2 and then write this whole term again, p of 2022. So this L of 2m plus 1, I can write this one like that, 3 f of 2m plus 1 minus 2 f of 2m plus 2, which is directly from our second theorem, 2m plus 1 divided by 2 times del by p of 2022. So at this stage, from this line, we can directly write it like that, 2 f of 2m plus 1 minus f of 2m plus 2 whole into del by p of 2022. So from this line, I can also write 2 f of 2m plus 1, and as our definition of Fibonacci number, f of 2m plus 1 can be written as f of 2m plus 1 plus f of 2m. Alright, so now I can multiply this with del by p of 2022. So from here I can write it like that, it will be equal to f of 2m plus 1 minus f of twice m whole times del by p of 2022. So from here finally we can get our conclusion.
Hello everyone, thanks for that time being, and yes, wish you all a happy new year